Hello and welcome back to my channel. My name is Veronica, known as Data Geek, and today I'm excited to walk you through a beginner-friendly project that combines Python, Jupyter Notebook, and machine learning, all to predict weather. So have you ever wondered how weather apps predict the forecast? Well, today we'll use Python, machine learning, to build a simple weather prediction. What we will learn today is how to load and clean weather data, how to build a simple predictive model, how to evaluate the accuracy of our predictions, how to visualize results using Python. So why weather prediction? Well, it's a real-world data analysis experience. It applies machine learning techniques in an easy-to-follow way. Also, you can build a project that you can add to your portfolio. And it is useful for anyone interested in data science and forecasting. So the tools that we'll be using today is Python for data processing and machine learning. We will be using Jupyter Notebook for running code step by step. And the libraries we will be using is Pandas and NumPy for handling data, Matplotlib and Seaborn for visualization, Scikit-Learn for building our prediction model. So the dataset we will be using is a real-world weather dataset that contains temperature, humidity, wind, speed, pressure, visibility, and more. So to get this dataset, I will put the URL in the description below for you to copy and paste into your Jupyter Notebook so you can follow along. So simple steps to build our weather prediction model. So we will do first is load the dataset into Python. Then we will explore and clean the data. We will prepare the dataset for modeling. Then we will train a machine learning model. From there, we will test and evaluate our predictions. And then the fun part is visualize and interpret the results. So this is how weather predictions work. Machine learning finds patterns in past weather data. It learns how temperature, humidity, and other factors impact weather. Then it makes predictions based on new data. So now that we're done with the overview, let's get started. Open Jupyter Notebook, load the dataset, and follow along. Grab a cup of coffee and let's start coding. Okay, so here I am in my navigator. So I use this to open up Jupyter Notebook. There are other softwares in here that you could use, but in this case we're using Jupyter Notebook. So you just click on Launch. And if you want to know how to download Anacanda Navigator, I will put a link to that video below in my description on how to download Anacanda Navigator to use Jupyter Notebook. So once you launch your Jupyter Notebook, you will see this. And to create a new workbook, you simply just click on this new button here and then click Python 3. And it will take you to this page. So this is your workbook, and you will have cells here. So you can add more cells by clicking this little plus button here, or you could click this plus button. Also, there's an untitled up here, which I like to title my workbook. So I'm going to just title this Weather Prediction. And then I rename it. Now you will see the new name, Weather Prediction. So in my first cell, I just want to put in a text. So I'm going to put this, instead of a code, I'm going to click here for this dropdown. There's code, markdown, and raw. So I'm going to do markdown because I don't want it to be a code. I just want it to be a text, kind of like just something that, like a statement, basically. So we want to put in here the question. So what is the question? So the question is, can we use past weather data to predict future weather conditions? So that is our question there. So now I can run this and it will just run as a text, not a code. Now in this cell here, I'm going to go ahead and go to step 1. We're going to install required libraries. But before this, I just want to do just a quick overview of this tutorial again. So we're going to predict weather conditions such as temperature, humidity, based on historical weather data. So this project is beginner friendly, and I will introduce concepts like data cleaning, future selection, and building a simple, and I mean simple, predictive model. So again, this is very good for beginners. So I'm going to do step 1, install required libraries. And again, I want to do Markdown. If I run this text, it will be this size. I want it to be bigger. A number sign and space, and press play. And now you see it's bigger. Also, just real quick, if you put more number signs here, the smaller the text it will become. But I'll just leave it as is. And then if you have not already installed Pandas, NumPy, Matplotlib, Seaborn, and Scikit-Learn, then you will need to do this next step. Otherwise, you can skip this step. So it's going to be exclamation, pip, install, Pandas, NumPy, Matplotlib, Seaborn, Scikit-Learn. And I'm going to go ahead and run that. You see your little asterisk sign is thinking, and then once it's done, it gives you a number. So now it has ran successfully, and I successfully have my libraries. So just to go over this installation, Pandas, this handles datasets. NumPy works with numerical data. And Matplotlib and Seaborn, these are for data visualizations, and Scikit-Learn is used for building machine learning models. Now step 2, I'm going to do this one as a markdown. I'm going to load the weather dataset. And I will run that code. And I need my number sign to make it bigger, so I'm going to double click in here and put that number sign to make my text bigger. Okay, so this dataset that we're going to be using, it comprises weather observations from like 18 locations across Europe, making it both tentative and accessible for beginners. So I want to import this data set using a URL. So I will link that in the description below so you can go ahead and again get that data set and follow along. But before I do that, I need to import my library. It's going to be import Pandas as PD. Now I will put a note here, URL of the data set on Zenodo. Now if you copy and paste this link in here, that's all you really need is the URL equals, and then paste in this link. Make sure it's single quotations on each side. Now we will load the dataset into a Pandas data frame. And to do that, it's going to be df equals pd dot read underscore csv open parentheses URL close parentheses. So you can call this whatever you want. You can put data, but in this case I'm going to just call it df, and then you're pulling this URL, which is this here. So it's like this is in that box, URL box, and then you're calling that box here, if that makes sense. So then now I'm going to go ahead and display the first few rows of the data set. Print open parentheses df dot head open and close parentheses, and then close that one again. Now I will hit play, and it's running that code. So you can see here on the bottom it says 5 rows, 165 columns. You can see my data set is now visible to view. This approach allows you to seamlessly load the dataset into Jupyter Notebook without manually downloading anything, which is here. And then we get to read the dataset, which we displayed here. So there's a date, month, cloud cover, humidity, there's pressure, sunshine, temperature, mean temperature, wind speed, humidity, so all these different weather types. So now that we have our data imported into Jupyter Notebook to view, and we displayed the data, now we want to display basic information about the data set. So df.info, open and close parentheses. You can see your data types, range index, columns, 165 entries, date to tours, temperature max, data types, memory usage. That's just like basic information that provides insights into the data types and missing values. Now we will display the summary statistics. And it's just print, open parenthesis, df dot describe. Open and close parentheses and close those. And now you will see that there's 8 rows, 106 columns, and we are looking at the statistics. So you'll see a difference from up here. This is just the head of your data, showing the dates, stuff like that, like just basic information on viewing the data. Now down here it's going to be different. It actually shows each column, so there's date, month, the cloud coverage, humidity, but it's showing the count, the mean, and the STD, which stands for standard deviation, the min, then there's 25, 50, 75, and max. So when you print this df.describe, it provides a summary of statistics of numerical columns in your data set. So kind of like a breakdown. So count here, that's the total number of non-missing values in each column. And then the mean is the average value of the column, like sum of values divided by total count. And then there's the standard deviation, which measures how spread out the data is. A high standard means values vary a lot. With a low standard deviation means values are close together. And there's the min, which the smallest value in the column. And then the 25%, so the value where 25% of the data points are below this number, this is also called the lower quartile. And the 50% is the middle value of the data set. So half values are lower, half are higher. It's also called the median, meaning it's not affected by extreme values. And then the 75%, the values where 75% of the data points are below this number, this is also called the upper quartile. And then there's the max. So the max is the largest value in the column. This is helpful because it helps understand the distribution of the data. It also identifies outliers, usually high or low temperatures. It's useful for cleaning data. So like the min and max values don't make sense. They might be errors in the data. So that's why this is also important. We're going to go to step 3. We will check for missing values. Oh, I forgot to change that to Markdown, and I will run that. So for check for missing values, all you have to do is type print, open parentheses, df dot is null, open and close parentheses, dot sum, open and close parentheses, and close that again. So I will go ahead and run that. So now it's showing each of my variables the column name. So there's date, month, so on and so forth, and each one has 0. So that means there's no null values. Otherwise, it would show the sum. So say, for example, if month had any null values, it would give us a number here, like, for example, 2. But there's nothing that we have in our variables that are null values. Identifying missing values is essential for data cleaning also. So now we will go ahead and do step 4, which is data preprocessing. And I will move that to Markdown and run that. At this step, we prepare the data for modeling. So step 1, we're going to go ahead and handle missing values. So to do that, we're going to do df equals df dot drop NAs, and open and close parentheses. So that one ran smoothly. I will add more cells here, a few more. So next we're going to encode categorical variables. So if the dataset contains categorical variables, convert them into numerical presentations using one-hot encoding. So that's what it's called. It's called one-hot encoding. So sometimes our data set has words or categories instead of numbers. So for example, say in this data set, weather conditions might have values like sunny, rainy, or cloudy, but machine learning models can only understand numbers, not words, right? So we need to convert these categoricals into numbers using a technique called one-hot encoding. So how does it work? Instead of replacing words with just one number, which might be misleading, we create separate columns for each category. So each category gets a 1 if present, or a 0 if it's not. To do that, I will go ahead and write a note first, because I like writing my notes. Perform one hot encoding on categorical variables. It's going to be df equals pd dot get underscore dummies, and then open parentheses df comma, and we're going to drop underscore first equals true. Then close that parenthesis. Now I will run that code. So we just performed one hot encoded on categorical variables. Now we will identify the target variable. So this is going to be, actually this is number 2, and this will be number 3 of step 4. Now we're going to future selection. This is to identify the target variables, like say, for example, temperature, and select relevant futures for a prediction. So I'll write another note here, define futures and target variables. To do that, we're going to do capital X equals df dot drop, and we're going to do the variable, which is this one up here, that basal temperature mean. So we're going to highlight that by dragging my cursor over that, do a Control C on Windows for copy, and then now click in this box to continue coding, and do Control V to paste, and then do a single quotation there, comma, axis, equals 1. Close that parentheses. Next, we're going to do a y. Lowercase y equals df, open bracket. And we will use the same variable. So we're going to paste again, Control V, single quotation, and close that bracket. Now I will go ahead and run my code. There's numbers here. That means the code's ran successfully. Go ahead and do step 5. We're going to split the data. Put this down to Markdown, run that. So we're going to divide the data set into training and testing sets to evaluate the model's performance. So I'm going to do a from Sklearn.model underscore selection. I'm going to import train test split. Train underscore test underscore split. And here I'm going to put my note. I'm going to split the data. So now it's going to be capital X, because that's what we used, capital X underscore train, comma, capital X underscore test, comma, now lowercase y underscore test underscore train, comma, and now do one for test, y underscore test. Now we're going to equal that to train underscore test split underscore split, and then we're going to do open parentheses capital X comma lowercase y comma then test underscore size equals 0.2 comma random underscore state equals 42, and close that with the parentheses. Now you can go ahead and run that code. So it's saying it's an invalid syntax. And, okay, so I had to put that up here. Now I can go ahead and run that code. Right here. I should have put it equal signs. Equal, not a negative. And then now run this code. And there we go. And now we will go to step 6. This is going to be a markdown. Number sign. Step 6. And we're going to build and train the model. And run that. So for beginners, a simple linear regression model is a good starting point. So that's where I started off saying that we're going to do a very simple model. So to do this, we're going to do from Sklearn, Sklearn dot linear underscore model. We're going to import the linear regression. And with the note, we're going to initialize the model. And we're going to do model equals linear regression. Equals open and close parentheses. And then I'm going to do a number sign for my note. We're going to train the model. So it's going to be model.fit, open parentheses, and within those parentheses, we're going to do an x underscore train, comma, y underscore train, close that with the parentheses. So we have our x train and y train inside the model.fit. So we will run this code. So now it's showing us the linear regression. And you can actually click on here, kind of like to see what the linear regression is. And it kind of gives you what it is once you click on that. Gives you a description, and it gives you some code examples on how to use the linear regression. So you can go ahead and read that if you'd like. But I'm going to go ahead and do step number 7. And we're going to evaluate the model. Change that to Markdown, run that code. So this is going to assess the performance using appropriate matrix. So we're going to do from Sklearn matrix import mean underscore squared underscore error comma R2 underscore score. Now we will make predictions. So we're going to do y underscore PRED equals model dot predict. Open parentheses, that's going to be a capital X underscore test. Close that parentheses. Next we will go ahead and calculate the mean squared error. And it's going to be MSE equals mean underscore SQUARED squared underscore error. Open parentheses, and we're going to do a lowercase y underscore test. And also under y underscore PRED. Close that parentheses. And now we will print, open parentheses, and we're going to do an F single quotation, MEAN with a capital M, space, and then squared error, SQUARED ERROR. Now we do the curly brackets, and it's going to be MSE, which we called it here. Let's make sure that's the same. Close curly bracket, single quotation, and a close parentheses. So the next note is we're going to calculate R squared score. So R2 equals R2 underscore score, and then score, open parentheses, y underscore test, comma, y underscore PRED, close parentheses. And again, we're going to go print, open parentheses. This is going to be F single quotation, capital R dash squared, score. And this little curly bracket, which is going to put our output, R2, curly bracket, and single quotation, close bracket, close parenthesis, close parenthesis. So as you can see, the stuff in purple is going to be what you want it to print, but this is your actual output. So MSE is going to output the mean squared error test with these two here. And this output here, R2, is going to pull in the R2 squared from these two here. So now we'll go ahead and run our code. I did. So this Y, actually I meant to put underscore. So go ahead and run that. So now you have that. So see how it says mean squared error? That's just the output it brings us, and then it gives us our actual numbers, our output numbers. So that's what this is, your mean squared error and R squared score. So again, this assesses the model's performance using appropriate matrix. Just to understand this, when evaluating our weather prediction model, we use the mean squared error, which is the MSE. and the R-square, which is down here. This measures how well the model is performing. Mean square error, MSE, it means that basically it's telling us how far off the predictions are from the actual values. So this number here, the lower the number, the better accuracy. So in our case, it shows the 0.1966 is very low. This is meaning our model is making predictions that are very close to the actual values. And the squared, the 0.9963, it's very close to 1. So this means our model is explaining 99.63% of the visibility and temperature predictions. So this is making it an actual model. So now we will go ahead and go to step number 8. We're going to visualize the results. And I'm going to change that to Markdown and run that. Now this is the actual fun part. This is the part I like to do is once I'm done cleaning the data and we split the data, we built the train and trained the model, and then we evaluated the model. Now we can actually visualize the results. So the first part, my libraries, import matplotlib dot pyplot as plt. So our note's going to say plot of actual versus predictive values. So we're going to do plt dot, and we're going to do this 5 times. So I'm just going to go ahead and copy this with the Control V, enter, and I'm going to paste this 5 times. Okay, so it's going to be plt dot scatter and open parentheses, and it's going to be y underscore test, comma, and then y underscore predict, close parentheses. Arrow down, and now it's going to be plt dot xlabel. So this is your labels. Open parentheses, single quotation, and I want it to title this actual values. Single quotation, close with the parentheses, arrow down. Oh, I have 2 dots, I only need 1. So plt dot, and then now my y label. Open parentheses, and I'm going to call this predicted values. Single quotation, close that parentheses. Now arrow down. And this is going to be my title. So plt dot title, open parentheses, single quotation, actual versus predicted weather conditions. Single quotation, close with the parentheses, arrow down. And now it's going to be plt dot show, open and close parentheses. Now I will go ahead and run this, and I will see my visualization. So just a breakdown of what this scatter plot shows. So this scatter plot helps us see how well our model predicts temperatures. So our x-axis here shows the actual temperatures from our data set. And then the y-axis shows our predicted temperatures made by our model. Our prediction is -9 for prediction and actual values, and then 30 for predictive and actual values here. So what does that mean? So the range -9 to 30 C, which C means Celsius, it means our model is predicting temperatures between -9 Celsius and 30 degrees Celsius. So why do we see negative temperatures? This means our model thinks some temperatures are below 0. If this is unexpected, it might mean we have to train the model better or check the data. So if most points are close to the line, our model is doing a good job. But if we see many far off points, we might need to improve our prediction method. So that's the end of this tutorial. Thank you guys for watching. I really appreciate your support. If you really like this video, don't forget to hit the like and subscribe button. Thank you for watching again, and I will see you on the next video.